Today's topic is data representation in machine learning. Data representation in machine learning. In machine learning, algorithms do not understand raw data directly. So how we represent data plays a crucial role in how well a model is learned plays a crucial role. In this lecture, we will study different ways of representing various data types so that machine learning algorithms can process them effectively. So the first one, introduction to data representation in machine learning. Data representation refers to the process of formatting and structuring raw data into a form that machine learning algorithms can understand. The main goal is to convert raw data into meaningful numerical formats. Effective data representation is very important because it directly affects model accuracy and performance. Different types of data, such as text data, images, categorical data, require different representation techniques. For example, text documents must be converted into numerical vectors, and categorical values must be encoded before giving them to the model. The next one, tabular data representation. Tabular data is one of the most commonly used data formats in machine learning. It is organized in rows and columns, similar to Excel sheets or database tables. Each row represents one data instance, and each column represents a feature or attribute. This type of representation is widely used in regression and classification problems. Most machine learning algorithms, such as decision trees and linear models, work very well with tabular data. So next one is text data representation. Text data cannot be directly processed by machine learning algorithms because it is non-numerical. Therefore, text must be converted into numerical representations. One simple method is bag of words, which counts word frequencies. Another popular technique is termed frequency, inverse document frequency, which gives importance to significant words across documents. Advanced methods like word2vec and glow2vec create word embeddings that capture semantic meanings. These techniques are widely used in natural language processing tasks such as sentiment analysis and text classification, word cloud analytics. So this text data representation majorly we will use in natural language processing. The next one, image data representation. Image data is represented using numerical pixel values. Each pixel contains information about color and intensity. Grayscale images store a single value per pixel, while color images use RGB channels. Images are represented as matrix or tensors depending on their dimensions. In deep learning, conventional neural networks or CNNs automatically extract useful features from raw pixels values for tasks like image classification and object detection. The next one is time series data representation. Time series data consists of observations collected over time. In this type of data, the order of values is very important. Time series representation is widely used in forecasting, anomaly detection, and trend analysis. Examples include stock prices, temperature readings, and sales data. Proper time series representation allows models to learn temporal patterns and make future predictions based on historical data. So the next one is graph data representation. Graph data represents relationships between entities. In graphs, entities are represented as nodes and relationships are represented as edges. This type of representation is used in social networks, recommendation systems, and biological networks. Graphs can be represented using adjacency matrices or graph embeddings. Graph embeddings convert complex graph structures into vectors so that machine learning algorithms can process them. Categorical data representation. Categorical data contains values that represent categories rather than numbers. Since machine learning algorithms require numerical input, categorical data must be encoded. One-hot encoding converts each category into a binary vector. Label encoding assigns a unique number to each category. These encoding techniques are essential for classification problems involving categorical features. The next one is numerical data representation. Numerical data represents measurable quantities such as height, weight, or income. However, numerical features may exist on different scales. To handle this, we use normalization and standardization techniques. Normalization scales values between 0 and 1, while standardization converts data to mean, 0 and unit variance. Proper scaling ensures that all features contribute equally and improve model performance over time. Next one, sparse data representation. Sparse data contains a large number of zero or missing values. Storing such data normally wastes memory and computational power. Sparse matrix representation stores only non-zero values, making computation efficient. This approach is widely used in natural language processing and recommender systems. Sparse data representation reduces storage requirements and speeds up machine learning algorithms. And the next one is structured versus unstructured data representation. So as it is very clear, in fact, data it is being categorized into 4 types: structured data, unstructured data, semi-structured data, and metadata. The structured data follows a fixed format such as tables or time series. Unstructured data does not have a predefined format like text data, images, audio data, and video data. Structured data can be directly represented in table form. Unstructured data requires pre-processing and features extraction before representation. Both structured and unstructured data must be transformed into numerical formats for machine learning models. And the next one is importance of data representation in machine learning. Data representation is a fundamental step in machine learning. Proper representation involves model accuracy, model efficiency, and learning speed. Feature engineering and pre-processing techniques help to convert raw data into meaningful features. Good representation also improves interpretability and generalization. In summary, even the best algorithm will fail if the data is not represented properly.